Have you ever stopped to think about the one part of your car that is literally the only thing touching the road right now? Not the engine, not the paint job, not the leather seats. Just four small patches of rubber, each about the size of your hand, holding up 2 tons of steel at 70 miles an hour. If even one of them fails, everything fails. Today, we're going to take you inside one of the most fascinating and surprisingly high-tech manufacturing processes on the planet. How tires are actually made, from raw rubber to the finished product sitting on your driveway. And trust me, by the end of this video, you will never look at a simple black tire the same way again. Stick around because we are also going to reveal how tires have completely transformed over the last 200 years. Starting from solid wood, moving to iron bands, and eventually evolving into the high-performance rubber tires we use today. There is a twist coming later in this video that most people have no idea about, so make sure you watch until the very end. Welcome back to Mass Production Process, the channel where we break down how everyday products are actually made on a massive industrial scale. If you are new here, make sure to hit that like and subscribe button. It genuinely helps this channel grow. Now let's start at the very beginning, because the history of the tire is honestly wilder than most people expect. Believe it or not, the very first wheels used on carts and wagons thousands of years ago did not have tires at all. They were just solid wood. Eventually, people realized that wood alone wore out too fast, especially on rough roads. So they started wrapping iron bands around the wooden wheels. This is where the very word tire actually comes from. It is short for attire, because the iron band was essentially clothing or dressing for the wheel. These iron-banded wooden wheels were incredibly tough, but they were also incredibly uncomfortable. Every bump, every rock, every pothole was transferred directly into the cart and into the people riding in it. For centuries, this was simply accepted as normal. There was no other option. Then, in the 1800s, everything began to change. Rubber started entering the picture, but not in the way you might imagine. Early rubber tires were solid, not filled with air, and they were mostly used on bicycles and early carriages. They were better than iron, but still stiff and heavy. The real revolution came when a man named John Boyd Dunlop developed the first practical pneumatic tire, meaning a tire filled with air, in the late 1880s. Around the same time, Robert William Thompson had actually patented an earlier version decades before, but it didn't catch on commercially until Dunlop's design took off. Suddenly, vehicles had cushioning, rides became smoother, speed became safer. This single invention is one of the most underrated turning points in transportation history. From there, the tire kept evolving at an incredible pace. Companies started experimenting with different rubber compounds, different tread patterns, and different internal structures. In the early 1900s, manufacturers discovered that adding carbon black, a fine, soot-like substance, to rubber dramatically increased its strength and durability. This single discovery is part of the reason why tires are black to this day, and it completely changed how long a tire could last. Then came radial tire technology in the mid-1900s, which changed the internal structure of tires so that the layers, called piliers, ran radially across the tire instead of diagonally. This made tires more fuel-efficient, longer-lasting, and safer at high speeds. Today, we have tires engineered for snow, racing, and off-road terrain, and even tires that can seal themselves after a puncture. It is a genuinely incredible journey from a simple piece of carved wood to the advanced engineering marvel under your car. So how exactly is a modern tire made? Most people assume it is a simple process, but in reality, a single tire can require over 200 raw materials and go through dozens of stages before it is ready to be sold. Let's break the entire process down step by step. The first stage is all about raw materials. Every tire starts with a combination of natural rubber and synthetic rubber. Natural rubber comes from the sap of rubber trees. This sap, called latex, is collected, processed, and turned into solid rubber sheets. Synthetic rubber, on the other hand, is created in a lab using petroleum-based chemicals. Manufacturers blend natural and synthetic rubber together because each type brings different strengths. Natural rubber offers flexibility and heat resistance, while synthetic rubber offers better resistance to certain chemicals and more consistent performance. Along with rubber, manufacturers add carbon black for strength, grease silica for improved grip and fuel efficiency, sulfur for a process called vulcanization, which we will explain shortly, and a variety of oils, resins, and chemical additives. Once all these raw materials are gathered, the second stage begins, which is called mixing. This happens inside massive machines called Banbury mixers. These machines are absolutely enormous, and they combine rubber, carbon black, silica, oils, and chemicals under intense heat and pressure. The temperature inside can reach levels hot enough to make the rubber compound almost liquid. The result is a thick black rubber compound that looks like dark, sticky dough. Interestingly, tire manufacturers actually create dozens of different rubber recipes for a single tire, because different parts of the tire need different properties. The tread needs maximum grip and wear resistance. The sidewall needs flexibility to absorb impacts. The inner liner needs to be airtight to hold pressure. Each is unique. After mixing, the rubber compound moves into the third stage, which involves shaping it into usable components. Machines extrude and roll the rubber into long, flat sheets. At the same time, separately, the tire's internal skeleton is being built. This skeleton includes layers of fabric cords, usually made from polyester, nylon, or rayon, which give the tire its shape and structural strength. There are also steel belts, thin strips of steel wire embedded in rubber, which run just beneath the tread. These steel belts are what give a modern tire its incredible strength and resistance to punctures. Without steel belts, tires would be far more fragile and prone to blowouts. There is also a component called the bead, which is a loop of high-strength steel wire wrapped in rubber, positioned at the very edge where it meets the wheel rim. The bead is what allows the tire to lock securely onto the wheel and hold air pressure without leaking. Now here's where it gets really fascinating. The next stage is called tire building, and it is done by a specialized machine called a tire building drum. Picture a rotating cylinder, similar in shape to the inside of a tire. Workers, or in many modern factories, robotic systems, layer the different rubber components one by one onto this drum in a very specific order. First comes the inner liner, an airtight rubber layer that will hold the compressed air inside the tire once it's finished. Then come the body plies, the fabric-reinforced rubber layers that form the basic structure. Next, the steel belts are added on top, followed by the tread rubber, which will grip the road. The sidewalls are attached on the edges, and finally the beads are locked into place at both ends. Once all layers are assembled, the machine inflates the structure slightly. This shapes it from a flat cylinder into a rounded form. At this stage, it is called a green tire, meaning it is fully assembled but has not yet been cured. If you saw a green tire at this point, you would recognize the shape immediately, but it would feel soft, sticky, and slightly squishy, nothing like the finished tire. This green tire then moves to arguably the most important and dramatic step in the entire process, called curing or vulcanization. This happens in a massive press. Inside this press is a mold with the specific tread pattern engraved into it, whether that's an all-season pattern, a performance pattern, or any other design. The green tire is placed inside this mold, and then the press closes around it with intense pressure. A rubber bladder inside the tire inflates with steam, pressing the rubber outward against the mold from the inside, while heat, sometimes reaching over 300 degrees Fahrenheit, is applied from the outside. This combination of heat and pressure triggers a chemical reaction involving the sulfur that was added earlier during mixing. The molecules form countless crosslinks, and essentially welding them together on a molecular level. This is the process called vulcanization, and it is genuinely one of the most important chemical discoveries. Before vulcanization was discovered by Charles Goodyear in the 1830s, rubber products would become sticky and soft in hot weather, and brittle in cold weather. Vulcanization solved this problem permanently, transforming rubber from an unreliable material into one of the most durable substances used in manufacturing. This curing process typically takes between 12 and 25 minutes per tire, depending on its size, and it is what gives the tire its final soul and durability. Once the curing is complete, the tire is removed from the press, and it now looks like a fully finished tire, black, firm, and ready to roll. But we're not done yet. Every single tire then goes through a rigorous quality inspection stage. Workers and automated systems check for any defects, bubbles, or structural weaknesses. Many factories use X-ray-like machines and laser measurement systems to inspect the internal structure of the tire without cutting it open, checking that the steel belts, fabric plies, and rubber layers are all perfectly aligned. Tires are also weighed and spun on balancing machines to check uniformity, because even a tiny imbalance can cause vibration. In addition, manufacturers randomly select tires from each batch to undergo destructive testing, meaning they are literally cut apart and analyzed layer by layer to make sure the internal construction matches the exact specifications required. Some tires are even mounted on wheels and tested on high-speed drums that simulate thousands of miles of driving in just a few hours. After passing inspection, the tires are labeled with all their essential information, including size, load rating, speed rating, and brand markings. From there, they are shipped out to distributors, retailers, and eventually to your local tire shop, ready to be mounted onto your vehicle. When you really think about it, from raw rubber sap collected from a tree to a fully engineered product, the journey of a single tire is an underrated feat. Now, let's talk about something most people never think about, which is just how enormous the demand for tires actually is on a global scale. Billions are made every year. Factories run production lines non-stop, 24 hours a day, 7 days a week, with massive facilities capable of producing tens of thousands of tires daily. Some of the largest tire factories in the world can produce enough tires in a single day to supply an entire small city's worth of vehicles. And because tires wear down and need to be replaced, the demand never actually slows down, it just keeps growing as more vehicles are produced worldwide every year. This is why tire manufacturing has become one of the most automated and technologically advanced industries on the planet, using precision engineering and robotics. If you are enjoying learning about this incredible process, we cover mass production processes just like this one every single week. So if you haven't subscribed, now is a perfect time. And while you are at it, drop a like on this video too, because it genuinely helps this channel grow and lets us keep making these deep dive videos for you. All right, let's get back into it. One thing that often surprises people is just how much engineering goes into the tread pattern itself. It's a feat of physics. Those grooves are carefully calculated using computer modeling to control how water is channeled away from the surface to prevent hydroplaning and reduce noise, how heat is distributed during high-speed use, and how grip is optimized on different surfaces like wet roads, snow, ice, or off-road terrain. Engineers spend months, sometimes years, refining a single tread pattern before it goes into mass production, running countless simulations and physical tests. Some manufacturers even have dedicated testing facilities in extremely cold regions just to test winter tire performance in real snow and ice conditions. Another fascinating detail is that tires are not one size fits all. A tire designed for a small economy car will have a completely different internal structure than a truck tire. Racing tires, for example, use extremely soft rubber compounds that provide maximum grip, but wear out incredibly fast, sometimes lasting only a single race. Tire manufacturers essentially have to become experts in chemistry, physics, and mechanical engineering all at once, balancing grip, durability, and efficiency. The tire industry has been rapidly innovating for electric vehicles. EVs are heavier because of battery packs and deliver instant torque, putting extra stress on tires. This has led to new tire compounds specifically designed for EVs, offering increased load capacity, reduced road noise, and improved efficiency for battery range. Pads. It's a perfect example of how tire technology continues to evolve, proving that even something as seemingly simple as a rubber tire is constantly being reinvented. From ancient wooden wheels to advanced radial tech and specialized EV compounds, the tire has quietly gone through one of the most impressive evolutions. It's easy to take tires for granted because we see them every day, but almost nothing else on your vehicle carries this much responsibility with this little appreciation. So now we want to hear from you. In the comments below, let us know where in the world you are watching this video from. We always love seeing just how far this channel reaches. And if you made it all the way to the end of this video, thank you so much for sticking around. It genuinely means a lot and it helps this channel keep growing. If you haven't already, make sure to like this video and subscribe to the channel so you never miss out on future videos. We will see you in the next video.